Hi, so welcome to a video that I promised and I forgot to attach the last one, but I don't know, I was already going on for 20 minutes, so who knows. But so changing orbits. And what we're going to actually talk about is changing orbits from circular to circular. I mean, there's whole fields that specialize in orbits, and you can go through all this. But what I want to focus on is saying, okay, so here's the sun. Let's say we're on the Earth. So we have our circular orbit, but what we really want to do is, out here we have Jupiter, and we want to send a rocket ship, and we want to, actually, the way I'm going to do this is I'm going to say, so we have a rocket ship that's been launched from Earth, and we want it to get it to orbit with Jupiter. So the slow orbit changes I talked about for the circular motion are not the way we end up doing this. Is basically we would have this rocket going here, and then we would do a large delta V, so a large change in velocity in, quote, small period of time. And I say small period of time because the time scale when we're talking about orbits is like now years, right? The time to go from here all the way around to here is 1 year. So for a small period of time, like this could maybe even be like a burn over a day, because that would still be, 130 or 1 over 360 of the total orbit. So this would be firing our rocket boosters for a heavy amount and then shutting them off. And the reason we do this large delta V is talked about how, like, this here is currently our radius. If we quickly change our velocity, so we're increasing the kinetic energy, which is then increasing our total energy while our potential energy change is the same, that's going to extend out the radius of our orbit. So now our rocket ship will start doing an elliptical orbit that goes in that direction. So we've been able to change our velocity so that we're going to reach the same orbit as Jupiter. So we now have this semi-major axis. Now, the thing is we want to stay in this orbit now, and if we don't do anything, then we would just go in our elliptical orbit, come back there. So we're not stuck in that orbit. So when our rocket ship is here, that's where, to stay in this orbit, we have to do, again, a large delta V in small period of time, so that this change will then make it so we're back into the circular orbit and we'd be orbiting along with Jupiter. And of course, for this to actually work, we would have to time everything so that we wouldn't start it when Jupiter was here. We would technically want to start it when Jupiter is somewhere over here, so that in the time that it travels, it ends up being that the rocket arrives at that point at the same time Jupiter does. And basically, orbital mechanics is crazy. And the fact that they can schedule these paths to go through and do all these sort of things, there's a reason when they're like, this is our launch date. We have to launch at this time within this window, because if they launch too late, then Jupiter might have been here. So instead of being where the rocket gets there, Jupiter's just a little bit ahead of it, and you're taking pictures from too far away. So orbital mechanics is crazy. It's its own specialty. We can start talking about base ideas of it, but actually going into the nitty-gritty details is, more than we're going to do. So, thanks for listening to my video on circular or changing orbits.